All right, so maybe let's start with burns. Now, I've seen this term zones of burn injury. What does that even mean? I mean, what are we talking about here?
So imagine like a target, a bullseye, right? It's not a uniform injury. It's like these concentric circles, areas of damage kind of radiating out from the center. And the source material talks about 3 main zones.
Okay.
The first one is right at the center, right? Where that heat or that damaging agent was the most intense. And that's called the zone of coagulation. And here, this is where the damage is irreversible. The tissues are essentially destroyed. Like, if you think about like cooking an egg, like that's it.
Oh, wow.
Right. The next zone out from there is called the zone of stasis. And in this area, blood flow, or what we call perfusion to the tissues, is really decreased. And this zone is interesting because it's potentially reversible. So you can kind of think of it like a plant that you haven't watered in a while.
Okay.
It's wilted and it looks unhealthy. But if you water it soon enough, it'll bounce back.
Right.
So similarly, with the right care, those tissues in the zone of stasis can heal. But if the blood flow isn't restored, then that area can progress to that deeper, irreversible damage.
So it's like this in-between zone, kind of.
It really is.
It's doing its best to stay alive.
Right. It's hanging in the balance.
Yeah, yeah.
And then that outermost ring is called the zone of hyperemia. And this is where you see, redness. The redness is from vasodilation, so the blood vessels are widening, and the body's trying to bring more blood flow to that area to help it heal.
Oh, okay.
And the actual tissue damage in this zone is minimal.
Yeah.
Like if you get a little bit of a sunburn.
Right, or a little bit of rub or something.
Exactly. So it's more of a reaction to the injury than like a deep injury itself.
That makes sense, yeah. Like you have the immediate impact, and then you've got that kind of struggling area around it, and then the body trying to do its best to kind of
contain it. Yeah.
Contain it, protect. I know that the depth of the burn also matters a lot. And I see the text talking about how that relates to the layers of our skin. So can you walk us through that a little bit?
Yeah, absolutely. So, burn depth really tells us how many layers of the skin are actually affected.
Yeah.
And our skin is 2 main layers that we're going to focus on: the epidermis, which is that thin outer layer, and then the dermis, which is that thicker layer underneath, which has blood vessels and nerves.
Right.
So starting with a superficial burn, this is only involving that epidermis.
Okay.
And think about, you spend a little too long in the sun, you get a sunburn.
Yeah.
Right? That's your classic superficial burn.
Yeah.
So the key signs and symptoms here are going to be pain, redness, and if you press on it gently, the skin will blanch.
Okay.
So it'll turn white for a second because the blood's kind of being pushed out of those capillaries. Importantly, there's no real swelling here. There's no blisters because only that top layer is affected. These burns usually heal pretty quickly, within about 3 to 5 days.
Oh, wow. That's quick.
Yeah. And typically they don't leave a scar.
Oh, that's good.
Just like a sunburn kind of fades away.
Yeah, yeah.
And then moving on to partial thickness burns, these are going to go a little deeper. So we're involving the epidermis and now some portion of the dermis.
Okay.
And there's 2 types here. So the first type is superficial partial thickness. So here we're going through that whole epidermis and into the very top layer of the dermis, but it's still relatively shallow within that second layer. But what you're going to see here is skin that's moist, often weepy, pink or red in color. And the hallmark of this type of burn is blisters.
Yeah.
Right. And these burns are also going to be really sensitive to touch and temperature changes. These usually heal in about 14 to 21 days. And similar to the superficial burns, they typically don't leave much scarring.
Okay. So a little more involved, but still not terrible.
Right. And then we have deep partial thickness.
Okay, now that's got to be pretty serious, right?
Yeah. So now in a deep partial thickness burn, that entire epidermis is destroyed and the damage goes much deeper into the dermis.
Yeah.
However, there are some important structures in the dermis that might still be intact. The base of hair follicles, sweat glands. So what we call epidermal appendages.
Okay.
So clinically, these burns look different. They tend to be pale with less moisture. And when you press on them, they might not blanch at all.
Okay.
Or they might blanch very slowly. And what's interesting is while the person might be able to feel a sensation of pressure, they often won't feel a pinprick. The wound itself might look, white or yellow. It's dry. It's not blanchable. These take longer than 21 days to heal.
Oh, wow.
And often require skin graft
to
help the process and to reduce scarring.
Yeah.
And there's a higher chance of scarring here, that difference in sensation.
Right.
Right. Being able to feel pressure, but not that light touch, really is a key indicator of the depth.
Yeah.
Because it tells us that, some of the deeper nerve receptors are still working while those more superficial ones are damaged. Kind of like, if you press firmly on your arm, you'll feel the pressure.
Yeah.
But a light brush might not register.
Right.
So,
interesting.
Yeah. And then the next step down is a full thickness burn.
Okay. So this is the worst of it, right?
Yeah, these are very severe. So full thickness is going to destroy that whole epidermis, the whole dermis, and go down into that subcutaneous tissue, which is the fat layer under the skin.
Okay.
And these have a very characteristic appearance. They're typically dry.
Okay.
And the color can really vary.
Okay.
It might be white, black, brown. The texture is often described as like dry and leathery.
Oh, wow.
And then vessels in the dermis are destroyed. You might see, thrombosed vessels.
Yeah.
So blood vessels that are clotted, or areas of charring. Now, a crucial and sometimes surprising thing about full thickness burns is that there's often no pain initially.
Really?
Yeah, because the nerve endings that transmit those pain signals are destroyed.
Wow. It's almost like it's so bad.
It is.
It can't even send a signal. Yeah.
So there's no sensation, no light touch, and potentially no movement in that limb if muscles are involved. These always require skin grafting to heal.
Okay.
And in some cases, if it's really extensive, amputation may be necessary.
Wow. That's hard to even imagine.
It is.
Okay, so we've got those levels of burns. Now I know the text mentions 4th, 5th, and 6th degree burns.
Right.
So how do those relate to what we've just been talking about?
So those are indicating that it goes even beyond full thickness.
Okay.
So a 4th degree burn goes through all the layers of the skin and into the fat.
Okay.
A 5th degree is involving the muscle.
Oh my God.
And then a 6th degree burn goes all the way down to the bone.
Gosh, that's just unbelievable. So obviously life-threatening in those cases.
Absolutely, yeah.
Okay. So let's switch gears a little bit. Still talking about burns, but the text talks about estimating the extent of the burns, and they have this thing called the rule of nines.
Right.
And also this London-Browder method.
Yeah.
What are these things, and why are there different ways of kind of figuring this out?
So when someone has a burn, it's really important to estimate the percentage of their body surface area that's burned.
Okay.
So their total body surface area, or TBSA, that's affected. And this helps determine the severity and guide treatment.
Yeah.
So the rule of nines is this quick and easy method that's primarily used, in the field, like pre-hospital or that initial assessment in the ER. And it basically works by assigning percentages to different regions of the body.
Yeah.
And most major areas are representing either 9% of the total body surface area or multiples of 9.
Okay.
So for an adult, the entire front of the torso is 18%. The back of the torso is 18.
Yeah.
Each arm is 9. Head is 9. Each leg is 18. And the genital area is considered 1%.
Wow. Okay.
So it's a very fast way to kind of get a general idea of the size.
Yeah.
Now with babies, it's a little bit different.
Okay. How so?
So children, and especially infants, have different body proportions than adults.
Right. Yeah.
Their heads are relatively larger. Their legs are relatively smaller.
Yeah.
So if you use the adult rule of nines on a baby, you would overestimate the burn size on the head and underestimate it on the legs.
Oh.
So for babies, the head is actually a much larger proportion. It's at 18% of the TBSA, while each leg is smaller, around 13.5.
Interesting.
The torso and arms stay the same as adults. So that adjustment for body proportions is really important for accurate assessment, especially in kids.
Yeah, that makes a lot of sense. So you've got the rule of nines for that quick assessment, especially out in the field.
Right.
What about the London-Browder? Why is that considered more precise?
So the London-Browder chart is a more detailed and thus more accurate method for estimating burn size.
Yeah.
And this is used, in the hospital, particularly with children, but also in adults. And it takes into account the fact that body surface area proportions change with age.
Okay.
So instead of just these 9 big regions, it breaks down into much smaller segments.
Okay.
And these percentages are adjusted based on the person's age. So there's this chart that accounts for those changing proportions.
Yeah.
So for example, the percentage assigned to the head decreases as the child grows.
Right.
Into adulthood, while the percentage for the legs increases. And then the total burned area is calculated by carefully assessing and adding up the percentages for each of these smaller areas.
Oh, okay.
So because it's more detailed and age specific, it gives us a more precise estimation of the burn extent, which is really valuable, especially in the hospital setting.
Yeah. I can see that being a lot more specific.
Okay.
All right. Well, moving on to types of burns. I think when most people think about burns, they're thinking about thermal burns. Right?
Exactly. I mean, that's what comes to mind first.
Yeah.
So thermal burns are caused by exposure to heat sources. So this could be, direct contact with flames from a fire, touching hot objects, or being exposed to scalding liquids, or even steam.
Yeah.
And the damage occurs when the skin and the underlying tissues are heated to a certain temperature.
Yeah.
And the depth of a thermal burn can really range from superficial, like a sunburn, to full thickness. And that really depends on the temperature.
Right.
And how long the contact lasts.
Yeah.
So think about, if you briefly touch a hot light bulb, you might get a little red mark.
Right.
But if you were to hold your hand on that bulb for a while, you'd have a much more severe burn.
Yeah.
So it's both the temperature and the time.
That makes sense, yeah. Okay, so what about inhalation burns? I mean, these sound particularly dangerous.
Yeah, they're very serious. So inhalation burns happen when you breathe in hot air or toxic chemicals, from a fire. And the damage here is to the tissues of the respiratory tract.
Right.
From the upper airways, so like your mouth and throat, down to the lower airways, which are your lungs. And these types of burns are a major predictor of mortality in burn victims.
Wow.
Because they can cause swelling that obstructs breathing, damage that lining of the lungs.
Yeah.
And then lead to systemic poisoning from the toxins.
Yeah. And chemical burns sound pretty awful too. I mean, things that are corrosive. So what causes those and how do they damage our tissues?
So chemical burns are caused by skin contact with, strong acids, alkalis, bases, or other corrosive materials.
Yeah.
And, these are things you might encounter in an industrial setting.
Right.
But they can also happen from, ingesting or mishandling, household cleaning products that are pretty harsh. And the damage isn't just from heat.
Okay.
It's from that direct chemical reaction with the tissue. So these chemicals cause what we call protein coagulation. So they're basically breaking down those proteins in our cells.
Okay.
As the chemical energy is converted into thermal energy, a key characteristic is that they often produce this grayish discoloration of the skin.
Okay.
Think about how like a drain cleaner can eat away at organic matter.
Right. Yeah.
Right? And even damage pipes. Similar processes happen when those chemicals contact our skin.
Yeah.
So the extent of the burn really depends on the type of chemical,
Yeah.
the concentration,
Right.
how long the contact was,
Yeah.
and how deep it penetrates.
Wow. Okay. And then there's electrical burns. I mean, it seems like there would be a lot of hidden dangers with these.
Yeah, absolutely. So electrical burns happen when an electrical current passes through the body. And that visible damage at the entry and exit points can actually be very deceiving because the most significant injury is often happening internally along that path of the current.
Wow.
And the heat that's generated as that electricity encounters resistance in the different tissues is what causes those burns. Hallmark of electrical burns is often an entrance wound and exit wound.
Right.
But those external wounds often don't reflect the extent of the internal damage.
Right. Yeah.
So the severity depends on the voltage.
Okay.
How long that contact lasted.
Yeah.
And the pathway the current took through the body.
Right.
So tissues that have lower electrical resistance, like nerves and muscles, tend to get damaged the most.
Yeah.
And the most dangerous scenario is when that current passes across the heart.
Yeah.
Because the electrical activity can disrupt the heart's normal rhythm.
Yeah.
And lead to cardiac arrest.
Wow.
So that's why even seemingly minor external electrical burns can have devastating internal consequences. It's like an iceberg. What you see on the surface is only a tiny fraction of the total damage.
Yeah, that's incredible. I would not have thought of that. So then finally, we've got scalding burns. This is, we hear about these all the time with hot liquids.
Yeah. So scalding burns are caused by contact with hot liquids or hot grease or steam. And what's really important to understand here is just how rapidly the tissue damage occurs.
Right.
That tissue death or necrosis can happen in seconds.
Wow.
Especially if the contact is prolonged.
Yeah.
Which is why even a brief spill of a very hot liquid can result in a significant burn.
Wow. Yeah. Okay. So the text mentions compartment syndrome in relation to burns. What is that?
So burn-induced compartment syndrome is a serious condition that can develop after these full thickness burns, right? So ones that go all the way around a limb or even the torso. So what we call circumferential burns.
Okay.
Or near circumferential. So when these deep burns happen, that damaged skin and the tissue underneath die, and they form this really tough inelastic layer called eschar. And that eschar basically acts like a tight, unyielding cast.
Wow.
So as the tissues underneath the burn swell due to the inflammation, the eschar prevents that swelling from expanding outward. And this leads to a really dangerous increase in pressure within those enclosed muscle compartments.
So it's like if you put on a sock that was way too small and then your foot started to swell inside it?
Yeah, that's a great analogy.
Okay.
So that increased pressure can then compress those blood vessels, reducing blood flow to the nerves and muscles.
Okay.
And if that persists, it can lead to irreversible damage.
Oh, wow.
To the nerves and the muscles, potentially requiring amputation. So some signs and symptoms to look out for are decreased pulses in that limb, severe pain that's out of proportion to the burn, and is worse with movement.
Yeah.
And then the skin might be pale or even bluish. What's especially critical is if the eschar forms around the chest or torso.
Okay.
Because it can restrict the chest wall expansion, making it really hard to breathe.
Mm-hmm. Yeah, that makes sense. That'd be awful.
So the treatment for this usually involves surgery called an escharotomy or a fasciotomy.
Okay.
And in an escharotomy, they make incisions through that eschar to release the pressure.
Okay.
And fasciotomy, deeper incisions are made through the fascia, which is that tough connective tissue, to further relieve the pressure.
Yeah. So a really, really important intervention to potentially save a limb.
Absolutely.
Now, I know that the text mentions those zones of injury again a little bit later. So maybe just as a quick review, can we just touch on those one more time?
Yeah, absolutely. So just to reiterate, that zone of coagulation is that central area of deepest irreversible damage. The zone of stasis is surrounding that. It's got decreased blood flow and is potentially reversible if treated quickly.
Right.
And then the zone of hyperemia is that outermost zone.
Yeah.
Where you have that redness. And that's due to those dilated blood vessels.
Right.
And that area has minimal